Hey, good morning. We're in the garage today. Today's project is we're going to work on the Rat Rig 3D printer. So, put this over here. So, here's the Rat Rig. I stopped using this temporarily because the thermistor went bad. This seems to be a problem in the Goliath hot ends. They tend to just, the thermistor just doesn't last. So I also bought two of these. I bought the Triangle Lab. It's the CTH, which uses a very similar style hot end, but the thermistor, I think it's a PT1000. It seems like it might be a better quality product as far as the thermistor. I've also seen guys using different. So this is thermistor that comes from Mellow. I've also been told that the Triangle Lab ones just tend to last longer. So I think what we're gonna do is we're gonna install the Triangle Lab ones, get the printer to work again. But we are also going to install, I have a whole bunch of stuff printed over here. We're installing the BRS Engineering Z access ball screws kits. This is one that I sourced all the parts myself. So I bought nuts and bolts and things. We're going to be using NEMA 23 motors instead of the NEMA 17 stuff that Rat Rig supplies. So hopefully the goal with this is to get better Z height control. It seems when I level the bed, it'll probably take 6 or 7 tries before it hits the Z axis calibration that I'm looking for. I'm hoping that the ball screws allow us to get that to happen a little bit better. Every once in a while, I'll actually air out and it won't allow the print to start because the Z axis did not meet the calibration we're looking for. And I'm at 0.003 is my limit that I have set, which is probably a little tight, but yeah, it seems to be warming it up has helped that a whole bunch. If I warm this thing up for 30 or 40 minutes, and then also I put a titanium axis, Y-axis I think it is, tube in here, which helped a bunch. So I'm gonna set this aside and we're gonna pull this out. Oh, so the thing we're gonna do, the NEMA 23 motors for this stick out the bottom. So they're gonna go here, obviously below, which means the whole thing's gonna have to raise. I have it setting on a little stand that I made. We're going to get rid of this and put it on wheels that have little feet on the wheels so it's not trying to roll around as it prints, but it'll be nice and stable, but give me access to put some storage underneath it. And when I want to work on this, I can roll it out instead of it's a bear to move right now. So check out how we do this. All right, we got it all pulled out. You can see it's a big printer. It's hard to move around. It's hard to work on because it's so big. I have let's go over here. I have an H2S. This has been fantastic. This is a great printer. I love it, but the Rat Rig actually is cooler in a bunch of ways, but it's a tinker rig. The H2S is my workhorse. I just want to make things happen. It's not a tinker. You're just going to make parts. This I tinker with a lot. So putting it on wheels, putting it on an easier thing to move around, I think will make this a whole lot better, just to be more willing to work on it because it's easier to get to. When it's against the wall over there, it's hard to move, it's hard to get to the electrical panel. It's just, I don't tend to work on it, so I just avoid it. So I'm really hoping this upgrade helps me make this project come together faster. Mind you, I have about 2,000 hours on this printer, so I've used it a fair bit. I'm just always making it better. This one. Why is my dog barking constantly? Hey. All right. Now we have 4 extrusions. So let's go check on the dog. Hey, what are you doing that for? Nothing over there. There's no kitties. Hey. All right, so this is the gist that we're going to do. These are little feet that I made. They have little clamps in them. They're bolting to these wheels. These wheels have a foot so that you can screw this down and down. And this comes out and essentially just makes the thing solid so it's not rolling around on itself. These are all made with parts from Sen. I drew these in Fusion real quick, real basic thing. I just key them together on a piece of extrusion with a rubber band, and then this is silicon bronze. I TIG welded it. You can gas weld this. It's just, I used the silicon bronze on this one because I was playing with it with another project. And 2, it doesn't heat the metal up so much so you have less warping. So when I'm sliding an extrusion in here, it holds it together very precisely. It didn't warp a whole bunch. So, and it looks kind of cool. I'll probably end up, I lie. I'm not going to paint anything. I never paint anything. I like the idea of painting, but I never do it. So we're going to... Kid, cocksucker. All right, so we're gonna drill the holes for the feet, or for the shelf. I'm gonna use this tool. I got it off Amazon. It was pretty cheap, and then I got these things from AliExpress. These are the style of inserts or attaching pieces instead of the typical like twist and wedge. Rat Rig went to these for their assembly, which is supposed to make everything easier. This is the, so you drill a hole here, and then there's a set screw inside this that locks in the adjoining piece. So I'm going to drill the holes, get this set up, and then I'll show you assembling it. All right, so I drilled all the holes for the inserts. The odd thing about it was the X tool thing, which is the other one I have. I have two of these things. This one's super cool in that it just slides into the extrusion. It has a couple of marks on it that show you if it's a 30-30 or a 20-20 extrusion, and it has a drill bit. Okay, no big deal. Cool. So I drilled all the holes, right? And then I went to insert the roll pin area, and it didn't go in. The hole was too small. So I went, okay, well, I'll just get a bigger hole. Made the hole bigger. Well, this one's all the way tight. It's not supposed to slide. It's supposed to pull this little taper. Whoops. The little taper in that pin is supposed to, there's a point on this, point on that Allen. The taper is supposed to draw it in, right? And you see it's elongated here, so if you're off, it draws it in, right? And it has a little O-ring to kind of know where the stopping point is. It's all the way down, and it's still not tight. It's not pulling this other extrusion tight, so that sucks. I do have this other tool that just clamps on. You can just set your own distance. But what sucks is I've drilled all four of these tubes for my shelf, and it's not going to work. So we'll deal with that later. I did go ahead and install my legs. I had these pieces cut from Send Cut Send. I've already showed you my feet. I'm surprised at how strong these tubes are. I was worried about it being a little weak without the shelf. So let's put this thing down. All right, so pull out our thing. Hey, we have a Rat Rig 3D printer freestanding. So let me set this up over here for us. So this moves around pretty easy now. We got the feet we can roll down. It's kind of a pain in the butt, but it does allow us to have feet. All right. It is a little wiggler, weak in the knees, I think, but hey, we'll get there. We'll add a shelf later. It kind of sucks that that's not going to work out, but you don't know till you do. So that's where I'm at. I'm probably going to assemble all of the components for the Z-axis, get those all as a unit, and then come over here and install them. All right, so I've gathered up all my parts for my BRS lead screw for the Z-axis. We're also going to go with the metal Wobble X joiners instead of the old hams. Lead screws are just off AliExpress. All of the parts, I actually printed these myself on my rat rig actually. This is in PPA CF. I know BRS, he was printing everything in a nylon with like a PP or a PA, whatever. You guys know what it is. It's a nylon material with carbon fiber in it. I printed out a PPA. It seems to be, they're just denser feeling and they just feel stronger. Like these things feel incredibly tough. I did go through all of his directions and some of his pin lengths seemed a little off to me because I had set up some of these and the pin is barely in this back edge. So I ordered slightly longer pins to change some of that. Yeah, I'm probably not gonna do a step-by-step of all of this, but you get the idea. So we're gonna be replacing that lead screw. I have the whatever Rose, the Roseworks aluminum mounts for all my motors. This is a cool upgrade, and I also have their Z-axis arms, but none of this works with the BRS lead screws. And you can see I already have the BRS Engineering all-wheel drive kit as well, and his belt tensioners. And this is running a Goliath hot end from Mellow Motors, so, or Mellow Fly, that's 3D printer stuff. You get the idea. We're gonna upgrade all these things, and I won't film all this, but I'll show you any struggle points along the way. So I have the BRS lead screw project all wrapped up. It is working wonderfully. I am ecstatic how well this is performing compared to the traditional, whatever screws they call them, the lead screws. The ball screws work so much better. It actually calibrates on the second go around when it does its Z tilt. It hits the calibration right away. It no longer has to retry, which is super cool. The Wobble X thingies, they're pretty good. I definitely understand people when they start talking about the balls come out of them, and that's a pain in the butt. I did see where BRS is working on an upgrade for the V-Core 4, and he's putting a spring here so that this becomes a little spring area. Let me get you in here and show you, see if I can get this to work. So, yeah, right in here. So having a spring that would latch all of this together so that it just stops trying to, you can come apart, right? And when it does that, it's really easy to get, let me switch the views. It's really easy to get these pins not aligned and have one of these things, doing that, right? And so, yeah. The other thing I did have to, I ground right here because when it comes up, it did want to contact the top of the lead screw mount. These are the aluminum ones from AliExpress. They fit the BRS kit or they fit the stock kit. BRS also makes a block here that put the bearing inside this. I think that's pretty cool. I didn't use it. I didn't need it. And so I didn't want to disassemble more than I had to. The thermistor in the hot end, I used the Triangle Lab one. Works perfect. I actually installed another Mellow Fly, whatever it's called, thermistor, and it failed right away. So I was like, damn you. So we just changed it to the other one. I have about 200 hours on it with this setup now. And it's working great. So let's turn this back around. There are some things that I need to change. Right? I'm always tinkering with this thing, let's be honest. I'm always screwing around. There are some things that need to get better. Primarily, when this goes back, it wants to hit these two, right? And so the beacon probe, which is back here, and this mount, there's just not enough room for two of them, right? And BRS trimmed the mount a lot to help this problem, but really what needs to happen is this just needs to be lower, right? And because if you straight view, it's just too high. The lead screws are cut in a very specified length, I think every 10 millimeters. And so you might be able to change, maybe it's every 50 millimeters. You might be able to change the length of the lead screws or the ball screws to accommodate this, but it still doesn't get you. You're just creating a new pain in the butt. You'd have to start raising the balls here so this becomes taller, so that shrinks and it still reaches. So, yeah. The other big dissatisfier, is the oozing, the nozzle ooze. So this hot end is crazy. It's a really, really strong hot end. It's a 100-watt heating element. Works great, but it definitely likes to ooze. And I have the retraction set pretty good. I have it calibrated very good for ABS and very good for ASA glass fiber. But it still oozes sometimes when it stops doing something, right? So when you start a print and it's going through the homing sequence and it wants to ooze, so it's just whatever. So because I have the Bamboo Labs and I'm looking at the Bamboo Lab stuff and how the Bamboo Labs operate, they do some things well and some things bad, right? It does really well is its cleaning routine every single time it starts a print. So it'll heat the hot end up, make a purge line, and then go clean itself again, and then start printing. Well, on the rat rig, you don't have an option for this because it has no place to clean the nozzle. The V-Core 4 improves this, but I think it's still lacking. So V-Core 4 on one of the arms, let me switch. I believe on the rear arm, they make the arm longer and they put one of those little silicone brushes on it. Like I said, it's in the back. And they're doing it, way back here. And they've increased this distance a little bit. And I think the brush goes this way. I still think it's not great. I looked at making a servo motor brush thing so the brush could, pull out of the way and pull, do one of these things, and using a servo motor rather than one of the cheap little hobby motors. This way I can put a limit switch on it and say, okay, move it to this position, and it goes out. It's stronger. It's just a bigger piece. And then, yeah, it has a couple problems in that because I'm running out of drivers. So I'd have to add another board to the system or make the tool head CAN bus. I got rid of CAN bus on this because it kept giving me data errors, and that might give me data after 6 hours of printing, and then it would screw up. So I got rid of CAN bus just for performance or reliability sake, which has been fantastic. I love the idea of CAN bus, and I tried it with CAN bus and I tried it with USB, and they both did it. They would just error out for data errors. So where I'm going with this, my next level of screwing off my rat rig, I have a whole bunch of stuff with the intent to build a V-Core 4. And I've been holding off on even considering building this until I really get this one closer, so I know everything I don't like and everything I do like. And I think what I'm going to do is in the V-Core 4, I'm going to build one. But I think instead of this 30 by 30 extrusion, I'm going to do a 30 by 60 extrusion and make all of this rail on all the top and all the sides longer. And I'm going to offset this so that this is more forward. The print bed will stay the same size, but I'm going to make this whole thing come forward. My goal with this is so that when the nozzle comes over here, this is all forward and the nozzle can go back farther. My intent is to make a stationary cleaning area and have IDEX, so you have one cleaning area on this side, one cleaning area on this side, and then you'd have the park thing, so after they clean themselves, they can park over here, But watching the Bamboo Labs, I think the cleaning and purging needs to happen over here, right? And happen far enough back so it's not off the, it's completely off the bed. So I can have a purge station, you know, when changing filament or whatever. So, and then the little nozzle swiper all can go back here and just stay here. It will have to do in the macros, not allow this nozzle ever to come in contact with this, so that, you know, this one has a safe area of this area, this nozzle has a safe area of this side. So it is going to take a little bit of screwing around with macros, but I think we can get there. I finished up my turtle box. I did not put a cutter in because I'm just not going to use turtle box right away. I realized that this is cool and this is a very nice kit, but I don't use the AMS on my Bamboo Labs nearly as much as I thought. Really what I think is better than the AMS is IDEX. I do know IDEX has its own problems, but the filament changes suck. Like, that takes a long time. It's a big waste. I have this huge pile of filament, little scraps. That sucks to see. I mostly print with engineering filaments. So I'm printing, you know, some low grade engineering stuff, so ABS, ASA. But I'm trying to print more with PPA CF for the products that are going to be, you know, the finished products. When you print with PPA CF, the support materials are a problem. They get stuck, and I've had a hard time with anything that uses support material in the PPA CF. It's almost impossible to get some of that stuff apart. What I've learned is using, it's another dissolvable filament. It's a lower temperature than the PPA, which makes IDEX required. So you have one nozzle running one temperature and then another nozzle running a higher temperature with the engineering filament, and it's laying down different filaments doing different things. You can't do that with the, you know, with one of these, with the turtle box or an AMS, because the nozzle can't constantly change temperatures depending on what filaments it's in it. You know, it's just not calibrated. It won't do that. So we're gonna go to IDEX. We're gonna redesign the rat rig frame. It's gonna take some time. I'm not buying a rat rig kit. I'm just gonna buy a whole bunch of parts. Actually, we can walk over there and look at that. Let's go see. I'll show you everything. I've been collecting all kinds of stuff for this. So I have, you know, just a ton of 30 by 30. I have the old lead screws they took off the rat rig. A pile of hardware. It's a whole bunch of nuts and bolts. All of the fasteners. You know, more Wobble X stuff, power supplies. I have titanium Z rails. So I think I have most of the components already here to build a V-Core 4. What is going to happen, because I'm going to do my own frame, part of what we're going to do is I have, where is it at? My CNC mill. We're going to mill the holes for the pins instead of trying to use the drill jig. That's just not going to work. I'm also going to be able to mill the face of the extrusions flat, and then so we have a nice precise fit. So it's going to take some time for me to get here, but that's where I'm at. I want to give you an update, tell you about how the rat rig, how it all worked out. I'm super happy with it, but it's tinker rig. We're going to tinker more. So stay tuned. I'll keep you updated with how this goes.